Hi friends, let's have a look at problem 2785, sort vowels in a string. This problem is, I guess, yesterday's daily challenge problem, and it's a very straightforward one. But here I want to share two formats of solutions as practices. In the first solution, we're going to use sort. More precisely, we're going to use comparison-based sort. Well, in the second format, we're going to use counting sort, which is non-comparative sorting. So with that said, our plan will be the following. First, we are going to digest the problem requirements, and then we look at analysis and codings. So with that said, let's first look at the problem statement. So here we are given a string. We want to permute S to get a new string T such that all consonants remain in their original places or in their original indices, while the vowels must be sorted in non-decreasing order of their ASCII values. So we want to return the resulting string. So here we want to emphasize that, so in this problem, so there are 5 vowels, A, E, I, O, U, and also their corresponding uppercases can appear in the string. So notice that upper cases have lower ASCII values than the lower cases. So if you look at the two examples, so they are very straightforward to digest. In the second example, there are no vowels, so we just need to return the string S itself. While in the second one, there are 4 vowels, a capital E and 2 little e and a capital O. So we are going to have capital E, capital O, and 2 little e's after we arrangement that, or those. So here the length is bounded above by 10 to the power 5, and S consists only of letters of English alphabet in uppercase and lowercase. So here notice the uppercase. So with that said, we are ready to do the coding. So actually, if we do not pay a lot of attention to the term complexity, so we can look at the sorting based solution. So let me first explain the first strategy. So for this, we're going to first linear scan S to separate consonants and vowels. Then for consonants, we remain them fixed in their original indices. Well, for vowels, we can do the sorting, right? And then we assign the vowels in the right place. So for this, there are some technical details. You can do different implementations. So here I'm going to do a sort, but I sort in a reverse order. And then I'm going to use pop operations to avoid keeping track of positions for vowels. So this is the first solution format. So let's first finish the coding for this part. So first I'm going to initialize a result. This is a list. So I'm going to use a list of lengths same as S. And then also I want to have vowels. Here I'm going to use a list because vowels can appear multiple times, so we do not use set here. But in practice, we can still use set or even dictionary. This is the second solution format. So once we do this, what we do first is a linear scan, right? So for I character in enumerate S. The reason here I'm using enumerate function is that I want to track those indices so that I can assign in results. So here, if character not in, so if it's not in vowel, let's see, let's copy all this. So let's see, A, E, I, O, U, right? So if character is not vowel, so we're going to remain it fixed in the corresponding index, right? Otherwise, so we're going to append all these things, vowels, append to the vowels list. So this is the first step. So in the first step, we achieve two things. First, we separate the consonants and the vowels, and the second one, so this is the one, and also we remain the consonant in their original index, right? So the second one is we do a sort. So this is a sort based on comparison, right? So sorting actually has two categories. One category is based on comparison, the other is not based on comparison. So typical sort, like we have quick sort or some bubble sort or merge sort. So all these things actually are based on comparison. So here we can do this vowels sort. So here I can do sort in a reverse order. So you will see why. So actually this, you can also do this if you like. You can use a key, right? So lambda function, so use s. So if you use identical function as corresponding to sort as the natural order. So if you use inverse, so that's going to sort in a reverse fashion. So after we sort, let's do the assignment. So for I in range, so length result. Actually, length result and length s are the same thing. So basically, I want to check if result I is null. So in this case, we are going to set this one to be vowels on pop. So because we have already sorted the vowels according and reversely, right? Each time you pop, you get the current ASCII current character with the smallest ASCII values in vowels, right? So that's what we said, that we can avoid keeping track of the positions in the vowels list. So after this, we just need to return the result. So this we use a join function result. Yeah, this forms one solution format. And let's do a test first. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the generic cases. But here, if you look at the term complexity, it's very easy to analyze, right? So for this is the linear, right? And then for this comparison-based sort is O of, that's big O of m log m. So here m is the number of vowels in s. So m is bounded by the length of s. Let's call it n, right? So we can see this term complexity is O m logarithm m and bounded by O n logarithm m. But for this one, it's also linear. So overall, the term complexity, the major or bulk part is this sort, right? So this is the first version of solutions. But we can slightly improve this. So we see improve. Actually, it's for this problem, it's so simple that it's no very significant improvement. So here I want to write a solution without using sorting in a comparison-based way. So let's copy this part maybe. So I will use this one as another version. So this is the V1. So here I remain this fixed, but here I don't want to use sort. So let's see. I want to let's see, do a counting, right? So let's see, vowels, collections, default dictionary. So we are going to use integer. This is essentially counter, right? So when we look at a vowel, so what we want to do is vowels, this character is count by 1. The reason is that we a priori know the order of these ASCII letters. So we keep order of vowels. So this case, let's see, I'm going to copy this part, build a list, and copy this part. So then what I want to do is that when I traverse this or scan this result, if I found a position which is none, so I'm going to set it from the smaller ASCII characters two larger ones. So because there are in total 10, right? So this is length 10, right? So and also we can know the order. So in other words, we don't need to do sorting, or more precisely, comparison-based sorting. So then let's do the assignment. So for I in range length result, right? Then we want to check if result I is null. In this case, we want to set a corresponding character, and in this case, this is all the characters and their count, but we need to check from smaller ASCII characters to larger ones. So what we do is an inner for loop for j in range, say 10. Actually, this is the length of k, so I would just use 10 because this is fixed. And then the k, let's make it some redundancy. K is equal, this is the k. And then we check if vowels k is greater than 0. And in this case, we can set result I to be the corresponding character. And then the vowels is decremented by 1, right? So once we have assigned value, we need to immediately break because we finished it, right? And then we just need to do the return. We return the same thing. Done, and the result. So this is another solution format. If you do time complexity analysis, so this will just linear. So here linear, this linear. Though we have two for loops because this is bounded by 10. This is essentially linear. So this way, actually, we avoided using comparison-based sort. But essentially, the problem is so straightforward, I would say the two solution formats are sort of the same. So now let's do a test. Expect string non-type font. Let's see, line 75. So let's see if let me check again. What's the problem? Sequence item 2 expect string instance non-font. For let's see, for I in range length, result is none. For j in range 10, so case and the vowels, then we set result equals k, and then vowels k. So this is the right? Let's see. That's 75. Oh, let's see our return. Let's see if it's better. Sequence item 2 expect string instance non-font. For I in range, result I is none. For j, k equals, oh sorry, here I guess it's k equals case j, right? So now let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So with that said, basically in this video, we practice two slightly different solution formats. So one is based on comparison-based sort, and the other based on counting sort, which is non-comparative sorting algorithm. So with that said, I guess that's about it for this video. Thank you.